go. So today we are going to graph lines and interpret our key features. First example, Little Whales Little Theater is an intimate 140-seat theater. The theater uses the equation 16x plus 8y equals 1,120 to ensure that each performance earns $1,120 to cover the costs for a children's production. A table of values is shown. So we see how many adult tickets and how many child tickets, combination of the two, right? Rewrite 16x plus 8y equals 1,120 in slope-intercept form. This is not new. This is like a whole chapter ago. Yes, what are we trying to do? Yes, making it y equals, trying to get y by itself. mx plus b, good. Okay, that's the form that we're trying to get it in. So if I have 16x plus 8y equals 1,120, we're trying to get this y by itself. So the last time we did this, what did we always do first? No. We never divided first. Never. Not one time did that happen. What did we always do first? Move the x. Move the x out of the way. How am I going to move 16x? We're going to subtract it. So now we have 8y equals, do I get to put those together? Why not? One has an x, one does not. So we're going to put negative 16x up front, and then our positive 1,120. Now what do? Now we divide each piece by 8. So we end up with y equals negative 16 divided by 8. Oh, careful. Negative 2. And then what is 1,120 divided by 8? Yep. What is it? 140? Are you guessing or did you do it? Someone just double check him, please. 1,120 divided by 8. Is 140? Okay, cool. Thank you. All right, so we've rewritten it, and now it wants me to graph the equation 16x plus 8y equals 1,120. So I'm not going to graph standard form. The reason why it told me to rewrite it was because this is way easier to graph for us, right? M means move, B is begin. So we're going to begin our line at what point? 140. Are we going to do it on the x-axis or on the y-axis? On the y-axis. Good. So it looks like these are going by 20s. 2, 4, 6, 8, 10. Yeah. So 120, 140. There we go. Now, how are we going to move? Good. Down 2 and over 1. The negative shows me down, and we always go over. Okay. Now, these blocks are going by 20. Right? I'm not going to try to count 2 and 1. We can do 2 whole blocks over 1 whole block. Does that make sense? Okay. Because our scales are the same. All of our boxes account for 20. Right? Does that make sense? Then we're allowed to go down 2 over 1. That's like going down 40 over 20, which simplifies as negative 2. Okay. So down 2 over 1, down 2 over 1, down 2. I try to fill in as many as I can on my graph. How can I go backwards? Up to which way? Left. Good. Go backwards. 1, 2, backwards. 1, 2, backwards. All right. And then you would take your straight edge. Let me get one. Oh, I didn't have those up for you guys, didn't I? Oh, I didn't. Do it with like a ruler. Okay. There we go. My lines are never straight, so I definitely need a straight edge. I don't know. They've been in my room for a couple of days now. I might see if someone claims them, and if not, I'm just going to throw them away. All right. Here we go. Any questions for me so far? Nothing is new. We went from standard form to y-intercept form, and we drew a line, right? All of that old news. Part C, circle the x-intercept. Where's that going to be? And place a point on the graph. So when we're crossing our x-axis, looks like it's about right here. It's like in between, though, isn't it? It's not 7. It's definitely not 7.
I say 7D.
Oh, okay. Well, I guess that is not 7. Okay. So we know it's in between something, right? It's not on a complete point. Complete the interpretation of the x-intercept. Lake Wales Little Theater will meet production costs when it sells 70. Ooh, is it adult or is it child tickets?
Adult.
How do you know it's adult tickets?
They're in the graph.
It says it right here in our table. It told me my X values were adult tickets. Okay, and then it told me up here that Y was child tickets. Good, so adult tickets. All right, now we're going to circle the y-intercept in the table and place a point on the graph. All right, so in my table, what represents a y-intercept? Some of us are still struggling with this. If I want the y, what has to be 0? The x. So is it going to be 0, 140, or is it going to be 70, 0? 0 and 140. This is our y-intercept, which also makes sense in my graph, right? Isn't that where we began our line, right? So this is our y-intercept. Circle the y-intercept in the table and place a point. All right, we did that. We circled it and we placed our point. Complete the interpretation of the y-intercept, okay? Lake Wales Little Theater will meet production costs when it sells 140 child tickets. Good, because my Y's were to child tickets. So we have interpreted our x-intercept. We've interpreted our y-intercept. They told me what x and y represented in the table, so we had to make sure we could apply that to our interpretation. All right, complete the interpretation for our slope. First off, what was our slope? Yeah, the -2/1, right? This is our slope, so that's what it's asking me to interpret. Is slope x over y or y over x?
No, y over y.
Slopes are the change in y over the change in x's. So the 2 applies to child tickets somehow, right? And the 1's going to apply to adult tickets somehow. Let's see what it says. For every blank child ticket sold, Lake Wales Little Theater needs to sell blank fewer adult tickets.
Oh, 40.
Our numbers, hold on. You're making up numbers. Hold on. Slope. We're looking at slope, right? The only numbers we care about are 2 and 1, right? So again, the first blank is for child tickets. Is that the 2 or is that the 1? That is the 2. So for every 2 child tickets, the Lake Wales Theater needs to sell 1 fewer adult tickets. Why does it say fewer? Why is that important? What told you that in the slope? How do I know I have to go down? The negative. Yes, the negative is what told me we had to go fewer. Okay. Part H, complete the table that gives other key features, and we're going to write a brief explanation of each. Here we go. My domain. What is the domain for this particular problem? It is not all real numbers. So domain is my x's, yes? Okay. So what is the least amount of X tickets, adult tickets, that we can purchase? 0. And what's the most adult tickets that we can buy? 0 to 70. Good. That's the domain for this particular problem. So between 0 and 70. Okay. So we can't do negative tickets, right? and we can't sell more than 70 because then we actually end up losing a profit. Okay. Nope. My range is my Y values. So this is our child tickets, yeah? So what's the least amount of child tickets that we can sell? 0. What's the most? 140. So for this particular problem, it's going to be between 0 and 140. And again, we can't have negative tickets, just like we said over there. And if we go beyond the 70 or go beyond the 140 for any of those, we lose profit, okay? All right, as my X values increase, what's happening to my Y values? They are decreasing. Oop. Decrease. Wow. How are you still moving? Pops all the bones. Okay, and why does that happen? Because really Part G explains it the best. Okay, for every 2 child tickets, they need to sell 1 fewer adult tickets to keep the balance. Why are we limited on how many tickets we can sell? Why can't I just sell an infinite amount of tickets? There you go. There's only 140 seats. Okay, so there has to be a balance here. So Part G explains that the best. Good. All right, so we are rewriting equations, old news. We're graphing lines, old news. And we are interpreting our key features. That's kind of new-ish. We did 1 lesson on that last week with like the coffee and the gift card kind of thing. Okay, we're just doing more of that. We're putting it all together into one problem. Here we go. The monarch butterfly is essential to the pollination process of many native and farmed North American plants. These butterflies migrate thousands of miles over several months. A Florida Department of Forestry scientist has been tracking their population since the 2005 migration cycle. The scientist uses the function b of x equals negative 35 plus 325 to estimate the number of butterflies, where x is the number of years since 2005. That is important. X is the number of years since 2005. And B is the number, come back, there we go. B is the number of butterflies in thousands. So that right there just told me what X and Y represent. Okay, I'm going to go ahead and label it on my graph. So this is our B, this is butterflies in thousands. And my X is number of years since 2005. Okay. All right, the very first thing it wants me to do is graph our function. Okay, do I have to rewrite my function? Let's see, they have given it to me as b of x equals negative 35x plus 325. Look, b of x is y, right? So it looks like we already have it in y-intercept form. Yeah? We okay with that? Okay. How are our values moving this time? By 20s? 1, 2, 3. Oh, yes, good. 25. So 325, that's easy to label, right? 325 is right here. But my slope is negative 35 over 1. That's kind of hard, right? That's kind of hard to graph the rest of this. Okay. What's up? Right under 300? Oh, right, yeah, negative 35. It would be like barely here, like that. But instead of guessing, I'm going to kind of go ahead and skip to number 2. It says solve negative 35x plus 325 equals 0. Because what is that asking me to find? They made y 0. So what are we solving for? Our x-intercept. It made y equal to 0. So number 2 wants to find my x-intercept. So if I find my x-intercept, I could just connect those two dots. Okay? If I have a y and an x-intercept, I can connect them. So let's do that. Let's see if that helps us. Tell me what to do for number 2. I'm going to write it bigger over here so we can see it. Negative 35x plus 325 equals 0. Help me get x by itself. What should we do first? Subtract 325. All right. Subtract 325. Now we have negative 35x equals negative 325. Now what do we do? Divide. So what is our x-intercept? Calculator friends. Negative 325 divided by 35. It'll be a positive something.
Divided by?
Mm-hmm.
325 divided by negative 35?
Mm-hmm.
Oh.
325 divided by 35.
It's
9.28?
Yeah, 9.285 second 1.2.
Okay. Okay. So it's approximately 9.28. We know it's positive because we had negative over a negative. So 9.28. Let's see here. Here's 9. That's 9.5. It's going to be right in between.
Where?
Okay, so I'll show you. So looking at my x-axis, 8, 8.5, 9, 9.5, 10, right? So this is 9. This is 9.5. So we're going to do in between 9 and 9.5. So I'm going to put my dot right here. Like that. And now I'm going to connect those guys. So not beautiful numbers, but that was still easier than trying to go down 35 and over 1, right, with the way the scaling is on this graph. Okay, it was easier to make our best estimate on where it's going to cross on the x-axis and connect those 2 points. All right. Which intercept, is the solution? Let's see if you're paying attention. Which intercept is the solution to negative 35x plus 325 equals 0? What intercept did that give me?
No.
Your options are x or y. This gave us the x-intercept. Good. It's okay. Okay. So that's 9.280, right? X and y. I'm kind of writing into part 6. Interpret the intercept. Ooh, okay. What did we say the x's were representing? There you go. Years since 2005. And what were my y's representing? How many butterflies? So what does that mean for the x-intercept?
0 butterflies.
When is there 0 butterflies? 9.28 years. What year is that?
2009.
Nope. It's from 2005. So what's 2005 plus the 9? 2014. So in 2014, that's okay. So that's 9.28 years, right, since 2005. In 2014, there will be 0 butterflies. All right, number 5 says find b of 0. So instead of b of x, we found b of 0. So what does that mean? I changed my x's in my equation to be 0 instead. Anything times 0 is 0. And what's 0 plus 325? 325. Okay, so that's the solving. Part 6, what intercept did we just find?
X. No. Right. Well, listen to me.
That was our y-intercept. Good. This was our y-intercept. So we had an x value of 0. That's what we plugged in, and we got a y value of 325. All right, so let's interpret that. Remember, this is years, this is butterflies. So how do we interpret our y-intercept? What did we always say the y-intercept was? It represented these something. It represents the start, the beginning, right? Our y-intercept shows me where something begins. There you go. And what do we consider the beginning for this butterfly thing? When? Yes, when was that specifically? There you go, in 2005. So at the beginning of the study in 2005, is it just 325 butterflies? There you go, 325,000 butterflies. Okay. All right, let's complete the table just like before. So what is the domain in particular to this example? Domain is my x's. These are my years, right? So in between what and what? In between 0 and, what was that? 9.28. Good. So in between 0 and 9.28. So we are not going to go negative. We're not going to go back in time, right? So can't have negative time. And we also know we have to stop at 9.28 because that's when we don't have any more butterflies. All right, range is y. These are my butterflies. What was the least amount of butterflies? 0. What was the most amount of butterflies? 325,000 technically, yes, but we're going to stop at the y value of 325. Okay. Same kind of reason. We're not going to have negative butterflies. And we started off with 325, so we can't go higher than that because that's all we had to begin with. As x values increase, what happens to the y values? They decrease. And we had a negative slope that showed us that in the equation. How are we feeling about it? Feeling okay? I'm sorry? You good? Did you just have a stroke? You feeling okay? No. All right, so our first two examples gave us equations, right? Well, the first one gave me an equation and a table. The second one just gave me an equation. Our third example just gives me a table. Okay, the table of values shows the linear relationship between x, which is the number of years since 1900, so these are my x's, and y, the percentage, whoa, let's try that again, the percentage of people in the world who can read, right? How can I graph something if I don't have an equation? What does the table show us? What part of the line is in a table? What's a table? What are those numbers? They're points. These are points in a line. Okay, so we're going to graph the point 0 for x, 21 for y. 0 for x, 21 for y. We're going to do our best guess. Then 10 for x, 27 for y. 10, what do these go by twos? 2, 4, 6, so there's 7. So 10, 27. Okay, make sure you can graph these. Don't try to look at my graph to see where I'm putting it. Okay, make it make sense. When x is 32, y is 40.2. So x 32 right here, y is 40.2. It's barely above. So right there. Do we see how I'm marking these points? An x of 48, a y of 49.8. Okay, an x of 48, that's here. A y of 49.8, that's there. So they're going to meet this point. All right. And then our last one has an x, an x value of 73. So right here in the middle. And a y value of 64 to 4.8. So right in the middle. So right about here. Nope, I lied. Right about here. There we go. All right, I'm going to connect these. Okay. How come I didn't draw an arrow on the other side? My x is number of years, right? Am I going to go back in time? No. So I know this line is going to begin at the y-intercept. This is where our study about people reading is going to start. Yeah, the screen froze. Place the checkbox. So you and your partner, place the checkbox. It's not asking what it is. Just check off which key feature that we use to help us graph the relationship. Okay, so you and your partner, check off what we just used to help us graph. All right, friends, did we use our domain to graph our line? Yes. Absolutely we did, because I didn't draw a line going both ways, did I? Because it made sense to not go backwards in time. So I definitely thought of my domain, my x values, right? That definitely happened. How about my range? Did we use range to help us? Whoop. I would say so, because my y-intercept, which is my range, part of my range, we know it's going up, right? What else did we use an x-intercept? No, because there isn't one, is there? Did we use our y-intercept? Yeah, we did. That was the very first point in my table. And I know that because my x value was 0, right? This is our y-intercept. Did we use a slope? I mean, they didn't tell us what the slope was. I guess we could have found it. If we wanted to, we could have used the slope, but we just plotted points. And then increasing or decreasing, we could look at the table and see that they are going up. So my graph should be going up. So I would definitely check this off. I wouldn't check off slope just because we didn't specifically find it. Does that make sense? We could have. If we would have found slope, I could check this box off. But we did not technically use slope to graph this line. Okay. Here we go. Last one, right? The equation negative 6x plus 10y equals 210. So now we just have an equation. It models the linear relationship. Okay. Place the check in the box of a key feature that can be determined using this equation only. So if I have this equation, could I find the domain of a line? Yes. Could I find the range of this line?
Yes.
Sure could. It's just a line. So what are those? If we're not applying it to real world stuff, what is it? Infinite. It's all of them, all real numbers. Good. Could I use this equation to find the x-intercept? Absolutely. I could make y 0, right? I could scratch this off and then just divide both sides by negative 6, and I could find my x-intercept. So could I find my y-intercept if I did the opposite? Could I scratch this out and just divide both sides by 10 to get the y-intercept? Absolutely, yes. Could I find the slope of this line? Yeah, because I could rewrite it into what? Into slope-intercept form. Good. And I could find slope, which means could I determine if it's increasing or decreasing? Yes. So we can do all the things. We can find all of them. And so now we are. Woohoo! All right. Write the equation negative 6x plus 10y equals 210 in sloped intercepts. Hey, there we go. So what are we going to try to get by itself? The x or the y? The y. Good. Where's my equation? Here we go. Negative 6x plus 10y equals 210. All right. We're trying to get the y by itself. So what do we move first? We're going to move the negative 6x. And Abraham, how are we going to do it? We're going to add it. So we're going to add 6x. So now I have 10y equals what?
6x.
Yep.
Plus 210.
There you go. Good. Now what are we going to do? Divide every single piece by 10. So we are going to get y equals 6 over 10 doesn't simplify to a whole number, but it does simplify as a fraction, right? We could divide them both by 2. That gives me 3 over 5. And then 210 divided by 10, well, that's nice. It should be just 21. All right, talk to your friend while I get the plug for my tablet here. What domain makes sense for the context? So my domain, remember, it's not all real numbers. What is it specifically for the context? Talk to your partner. All right, is domain x or y values? They are x values. And in this context, what did x values represent? What were they up here? They were years. Let's see here. Oh, number of years since the year 1900. Right? That's what x represented. So what domain is going to make sense? What can x values can we use? So we definitely can't go below what? 0. Good. So we definitely can't go below 0. Do I have a limit on how far we can go in time? No. Looks like we can keep going. So for this one, our domain is going to be any x value that is bigger than or equal to 0. 0 is representing the year 1900. Okay, what range is going to make sense? Is that my x's or my y's? These are our y values. So what's the lowest y that we have? No, my lowest y is not 0. What's our lowest y? 21. Good. And then it goes up from there, right? Without stopping. So my range is going to be y's that are bigger than or equal to 21. Because that was the starting percent of people who could read in the year 1900 when this study started. All right, number 7, determine the x-intercept. Okay, so we have to solve. I'm going to use our original, negative 6x plus 10y equals 210. Because to get my x-intercept, we can just take this part out. Negative 6x equals 210. And let's divide. Yeah. What is 210 divided by negative 6? Negative 35? Yes? Okay. So we get negative 35 if my y value is 0. Interpret that. What does that mean? My x value was years, right? So negative 35 years from 1900. So what is that? 1865. In the year 1865, what does the 0 represent? What are my y values? What are my Y values? Look at my table, guys. What are the Y values? Look, what does it represent? I don't want numbers. Percentage of people in the world who can read. So this is saying in the year 1865, what percent of people in the world could read? No one. 0% of people in the world can read. Does that make sense? No, that does not make sense. People could definitely read before that. They wrote the Declaration of Independence in 1776. We could definitely read by then. Okay. Question, does that mean, is this a viable solution? No. Good. All right, determine the slope. All right, well, I should already have that somewhere, shouldn't I? I believe I got it in my, when I made it y equals mx plus b. What was our slope? 3/5. Good. Interpret that. Okay, so remember, it's y over x. Let's see. So percent is what, my y values? Percent is y, x is years. Okay, so what did you say? Oh, switch that. For every, yeah. No, you're good. For every 5 years, are we going to increase or decrease by 3%? Good. The amount of readers increases. Increases. By how much? By 3%. Good job. Good. So what I did right here is a great way to kind of set it up for you. I know slope is y over x. In this problem, my y's were percentages, my x's were years. And then you can put that next to your actual numbers, and that can help you write out that sentence. You could also say the percentage of readers increases by 3% every 5 years. You could like flip-flop it if you want to. Okay? You are going to use your notes to do your homework. I am going to check it for a grade tomorrow. Yes, I'm going to walk around and check, did you try your homework? Page 75, numbers 1 through 10. Use your notes to do your homework. It is a grade tomorrow.